And just to be clear, I've tinted the forest green as my source of pollinators to surrounding coffee. And the question is there some zone near forest where coffee growers are getting this benefit, a subsidy of wild pollination, and those too far away are not? That's the main question I'm asking. So I asked this question in a field in a farm in Costa Rica, where I could find a big homogeneous area of coffee. This is a large coffee farm in yellow, and 2 forest patches of significant size. And I just did a distance transect from each, near, medium, far, coming into the center of this, with the far sites being 1.5 kilometers away from the nearest forest, which is farther than even honeybees typically fly. Right? So that's the design, trying to get a nice isolation gradient from a source of bees and ask what happens in coffee fields as increased isolation happens from sources of bees. So we went out to all those sites. Sorry, the blue dots in there are the field sites. And at those sites, we just watched coffee while it flowered and watched bees visiting and got a sense for who was coming and how often. And we found that, again, here's this near, medium, far design. And now I'm showing the number of visits to flowers in a standardized way. This is visitation rate, how many bees are coming, how often. You can see twice the visitation rate in sites that are near forest and farther away, right? So coffee farmers near forest are getting a lot more attention from bees, wild bees, than those that are further away. And pollen deposition follows the same thing. So you actually pluck the stigma out of a flower, squish it under a microscope, and count pollen grains, which takes forever. But the idea is, that visitation is ramifying into a doubling of pollen deposition rate. So pollen's moving around more in those near sites. So then we asked, okay, well, is coffee responding? Does coffee care about this at all? And to do this, there's just a classic pollen limitation experiment where you leave some branches open to